Let's solve this system of equations from the British Mathematical Olympiad 2012. We have the equations x squared minus 4y plus 7 equals 0, y squared minus 6z plus 14 equals 0, and z squared minus 2x minus 7 equals 0. And we have to find the values of x, y, and z that will satisfy these equations. Alright, when I first saw this problem, I immediately thought of adding the three equations because I observed that we can actually form an equation containing perfect square trinomials which we can use to analyze the problem. So let's do that. Now I'm going to group the terms with x, y, and z respectively. So if we add this, we can have x squared minus 2x plus y squared minus 4y plus z squared minus 6z plus 14 equals 0. Now, we can actually split 14 into numbers 1, 4, and 9 so that we can complete the squares. In particular, we can have x squared minus 2x plus 1 plus y squared minus 4y plus 4 plus z squared minus 6z plus 9 equals 0. Note that we can actually derive the same thing by adding 1, 4, and 9 and then subtracting the same numbers at the end. Now, these trinomials can be written into x minus 1 squared plus y minus 2 squared plus z minus 3 squared. So the left hand side is equal to 0. Okay, now the only way this one is equal to 0 is when the square of x minus 1 is equal to 0, y minus 2 squared is equal to 0, and z minus 3 squared is equal to 0, which further implies that x must be 1, y must be 2, and z must be 3. So these are the values of x, y, and z that will satisfy the system of equations.